Thank you. And so we'll, as we've just had with the last panel, a broader discussion around circularity and where it's coming from. We're now moving directly into something very much in the more pragmatic experiences and a direct project on car-to-car recycling between Europe and China. So I will hand the floor directly to Jingyue and let her begin. And she should have the clicker as well.
Thank you, Jochen, and thank you for all the colleagues here to make this happen. I'm Jingyue from GIZ China, and I'm also happy to bring all our partners over here to talk about the car-to-car recycling in China, but with all the efforts from all the private sectors all around the world. So background of the project is actually everyone knows the heated discussion on the EU end-of-life vehicle regulation, while China is also taking very similar approaches to consider the EPR pilots in China for the automobile sector, and also they are also doing a lot of encouragement of using the recycled contents in the vehicles. However, we still see a lot of challenges that we are kind of lack this kind of value chain stakeholder collaboration to reach the car-to-car recycling of the plastic. And therefore, we gather a lot of partners over here to try with the value chain stakeholder collaboration to enrich or to try with the plastic circularity from car to car. And you can see the journey actually started from GIZ that we have initiated this collaboration together with the partners, including the dismantler, the green eco manufacturer on the right side, who is doing the efficient collection, and then they have dismantled the car light from the vehicle, and then they send it to Ausell, where Mr. Liang will talk later, that Ausell is actually doing the piloting. Before that, they also remove the coating and do the cleaning, everything. And the 100% of recyclates has been sent to Covestro, where Anya will present later. And then after the compounding, the certain amount of the recyclates has been made into the new material and sent to the very important two OEM, including Volkswagen here and also NIO. Yes, and the two OEM, they are doing the quality test, who will also share the results with us. And one of the very important partner, the Rheinland, who is actually along with the entire journey and to do the material tracking so that we can make sure that all the plastic is coming from the end-of-life vehicles. So this is actually what we are planning in the project. And in the past, I think 30 months, we are happy to share some results today. And beyond this, you can also scan the QR code because we are also doing a baseline study in China about the plastic circularity in the automobile sector. And as our partner from Green Eco Manufacturer cannot come today, I will speak on behalf of them. So yes, this is the journey of the dismantling process from GEM. You can see that from the journey, it takes normally only 10 minutes to do all the pre-treatment, dismantling, everything here. And they are now in the project is removing the car light from the car, but without further approaches, because we have to do an internal experiment. This is the challenge number one. If they have actually removed the shell from the car light, it will take extremely long time, and they have to invest a lot of personnel and generates additional cost. And the challenge number two, after we do the analysis, we find out that if we calculate the material selling part, 90% come from the metal, and for plastic, to sell the plastic, it takes only they can earn only 4%. And they are quite lack of the motivation to dismantle the plastic further refined. And this generates the challenge that we have to pay additional logistic cost because we have to travel or send the car light in that format to the Ausell. But we are also happy to hear what Ausell is doing, and I will pass to our corner here.
Okay, thank you, Jingyue, for the introduction of the GIZ and also our upstream, the process. So this is Liang from Ausell. It's my honor to share with you that what we did in Ausell for the wasted, the vehicle, the lightings. So you can see that because generally that the people always think that for the wasted, the automotive, the lighting modules is very easy to handle, and you just take out from the end-of-life vehicles and you do some disassembly and just the cleaning. So this is usually that people is considering how we treat with the wasted vehicles, the lighting part. But in reality, that the process that is more complicated. And I will share with you that this is very simplified process. And also you can see that including at least another 4 steps. And first you need to ensure that your lighting cover has been disassembled with the lighting, the base part, and also you need to remove all of the electronics part, all of the glue, and do some preliminary cleanings to remove all of the dust. And finally, that will go with the deep cleaning to remove the coating on the vehicles, the lighting covers. So you can see that it's before the coating removal that you need to do a lot of steps. So from Ausell that we have developed our preparatory cleaning process to ensure that all of this contaminate has been removed during the process. So what is the result we can achieve? So let's see the result. Let's see what magic that we apply for the vehicle lightings. So at the bottom left part, so this is the photo from the microscopy that you can see at the left part that it has been a lot of contaminants, a lot of dust inside. But after the cleaning, after we make the pilots, that you can see there are no black spikes. There are no contaminations. And also that for the automotive, its mechanical properties is important, but also that the surface, the color is also more important for the recycled product. So you can see that after we apply for our magic that at the beginning, the flake looks a little bit yellow and it looks a little bit translucent and a little bit dark. And after we apply for our cleaning process, and finally you can see that we improve the transmissions and reduce the haze and also reduce the yellowness. So the product, the pallets we produce can give our downstream partners the freedom on the product designs and also the application range. So later on, I will pass my microphone to our downstream partners, Anya, to share with you how Covestro do with our pallets. So Anya, it's your turn.
Perfect. Thank you, Liang. So, good afternoon, everyone. My name is Anya sorry, I don't need that. My name is Anya Rota, and I work as a global mobility manager at Covestro. Covestro is a global plastics manufacturer with a strong focus and commitment on circularity. And today I'm very pleased to point out our role in this joint project on closed-loop ecosystem for end-of-life headlamp recycling. So on the left-hand side, you see a big pile of waste coming from end-of-life headlamps. And actually, this represents a great opportunity as we have a selectively sorted waste stream available. So at Covestro, we make sure that this pile of waste actually is transformed into high-performance polycarbonate pellets that you can see in the smaller bubble next to it. So we call these our car-to-car grades. And these car-to-car grades are specifically engineered to fulfill OEM specifications. And we will also help the industry to fulfill the upcoming ELV regulation in Europe. So what makes our car-to-car grade so special? First of all, we have high-performance materials that are comparable to virgin materials. Of course, they also comply with all regulatory requirements on hazardous substances. So we will grant OEMs the full confidence in both safety and sustainability. The feedstock that we talk about is derived from end-of-life vehicle headlamps, and it's also TÜV certified to also grant full transparency and traceability over the value chain. The feedstock supply chain is well established within the APEC region so that we ensure a reliable sourcing in China. Concerning material specifications, our first pilot grades actually offer a recycled content of up to 50%, and we can also offer various colors. Furthermore, a quality control system is established to ensure lot-to-lot consistency. And finally, the OEM specification process is in progress, which you will also hear later on. And this paves the way for a broader adoption of these materials in future car applications. So from our side, in this joint project, Covestro brings its expertise in polycarbonate engineering. And with these car-to-car grades, we also set a path forward to drive the automotive industry towards a circular future. And we as Covestro are very proud to be part of this joint journey. Thank you for your attention. Okay.
Thank you. So hello everyone, my name is Kraemer. I work for Volkswagen Group in China. And Volkswagen Group in China. Yeah? And our role in this project was actually to evaluate and test the material quality from an OEM perspective, yeah? And also see if it can be used and applied in our automotive parts. Therefore, we did a two-step approach. We firstly tested the material itself, yeah, so the recyclate, and then produced in a second step with a supplier a part, and then tested also the part. And when defining how we test, it's really important what kind of function does this part have? Is it an exterior part, an interior part? Is it painted or not, and so on. So this is very crucial to know. Yeah? And for that project, we chose an interior part from the middle armrest between the driver and the co-driver. These are actually two parts which are assembled together. And these were the parts we chose for that project. And yeah, when we tested, we applied then the same quality standards which we also use for virgin material. Good. So the first step was our material testing. So we received from Covestro not only the recycled material with 50% recycled content, but also virgin material. Why? Because we wanted to test both to compare them. And then we did several basic tests, like for the mechanical properties, for flowability, for emissions. And then on top, we went a bit further and also tested the properties then also in low temperature, high temperature, in different humidity conditions, after heat aging, and so on. So we did a very thorough testing to compare these materials. And then on the right side, the last thing what we also tested is if we can find any coating substances still in this material. For us, this is very important to have a very, very pure material, yeah, because it would have an influence on the mechanical properties. Yeah, but the result was very positive, so it could fulfill our VW requirements. The recycled material also was very similar in the performance to the virgin material. And we also did not detect any coating substances in this material, so this went very well. Yeah, and then we produced the part and we tested the parts from this armrest, which I mentioned before. We went to the supplier, also checked there the injection molding process. We did tests in different environmental conditions, different temperatures, heat storage tests, and so on. We tested because it's an interior part. We also tested for odor, so for the smell, and also for flame resistance and light resistance. So we did a bunch of tests, yeah, and also these tests were successful. Yeah. Also quality comparable to virgin material produced parts. And one thing also worth to mention is that our supplier did not have to modify his tooling, which when using the recycled material. This was also quite important. Yeah, to sum this up, so from our point of view, this was a very successful feasibility study. Yeah, the material quality was very good. We didn't detect any coating residues, where we had concerns, to be honest, at the beginning. We successfully tested it in the interior parts, and we see a potential that this could also be used in other parts. Yeah? But nevertheless, there are some topics which, from our point of view, still need further studies. Yeah? We received material from one batch. Yeah? To be able to say if we could use this in a huge volume, we would also need to have ensured that this works then in all batches, yeah, and the material quality is always the same. And then what I forgot to mention before, we also do functional tests for our parts. In this project, we could not do this for the armrest, so this also still would need to be done. And if we would want to apply this material also to other parts, then, as I mentioned at the beginning, each part, depending on function, where it's located, and so on, needs specific test procedures. Yeah? So then we would need to do additional or other kinds of tests, probably. Yeah? But overall, very successful project, at least in our thinking from our side. Then I would hand over to Neo.
Thank you, Simon. Right? I'm from NIO. I don't know because Volkswagen is probably well known, but how many of you have heard about NIO? Very good, thank you. I think I'm encouraged to continue to tell about the story. I think NIO about. Did I wrong?
Yes. So.
You need to click.
Yeah. Okay, so we should go to the blue sky. That is exactly what the NIO stands for. So right, you can see that. That's exactly why we participate in this program, because NIO is created with a formally belief called blue sky coming. And that is exactly why we want to establish another company called NIO. And this is, we want to use the smart EV technology and by changing really the climate and also give the blue sky first in China. And of course, we have also our values. But in the program, what we worked together with this program is actually we believe the innovation is working hand in hand with circular economy. And that is also the reason the NIO is, have been practicing the innovation together with the circular economy. And you can see on the left hand, basically, we defined from the supply chain side to the manufacturing side until to the user side. So in each of this value chain, we try our best to practice and make the best practice. And as you know, partially of our car body is made by the aluminum. We started also recycle the aluminum, but we also doing some other material because we believe in the smart EV industry, we should be the pioneer to really practicing the circular economy. And if you can see, of course, our colleague and partner have presented from Ausell to GM and also Covestro. And finally, I think what we do also in the practice of NIO, we even created a sustainable brand for NIO merchandising called the Blue Sky Lab, in which we use the leftover material, for example, the leathers for the seat and also the airbag into a fashion, either a clothing or a bag. And finally, we could, for 1 month ago, we could really publish the first blue book together with TUV, Rheinland. I think the colleagues will present later on as well, and with Chinese Cartec together. And exactly on this project, we started to use exterior parts. As you can see in this photo, that is the cover of the camera parts of the sub-brand of NIO called Firefly. And this car is the first NIO small smart EV. And we want to also focus, the target customer is the Z generation and the millennium generation who really put a lot of effort and they put a value on the circular economy. And this part is approved to be very successful. And we believe also that's only the start of a young company of a NIO with 11 years old. But that is give us a good confidence that we will be the pioneer as a circular car maker also in the long term. Thank you. Is that?
Thank you. Yes. My name is Jia Liu, and I'm from TUV Rheinland. I'm responsible globally for our sustainability services, namely carbon ESG and circularity. a quick introduction to TÜV Rheinland. It's global technical service company, independent certification company, headquartered in Cologne, Germany, operating globally with 20,000 employees. We provide our certification, testing, and training services to customers around the world to ensure the world is becoming a safer place. In this particular project, we played a very unique role. I would say we are very privileged. We see all the parties here putting their effort to make sure this innovative circularity project is going into the reality. We had the privilege to witness every stage of this project. We acted as independent traceability verifier. We traveled with these plastics from the beginning till the end with our independent witness, eyes, and the technical services to ensure the integrity and the traceability of the recycled material. During our verification project, of course, we rely on internationally recognized different standards, such as ISO 14021 for recycled material declaration, and a chain of custody standards such as ISO 22095, and in particular for the plastic-related standards such as EN 153. 153.43, a lot of numbers. And of course, all the standards are very important, but it's really about the methodology we apply during this verification process. That's what made it really credible and robust of this project. So as you can see, all the other speakers have all explained the whole recycling process from the headlamp till the end of the parts. So we have traveled with them at each stage of the value chain of recycling and reuse and reapply of these plastic materials. So what we focus is really a qualitative and a quantitative approach during the verification process. Within the single suppliers, we focus on qualitative sides of them, such as management system, whether they have robust SOP in place, what type of traceability models each collectors or each processors are using it, and whether they have internal verifiable mass balance system in place for us to trace this data system. And between the two suppliers, between upstream to the downstream, between the two companies, we really focus on the transaction records, transportation records, and the production records, and all the data from A to B are matching so that the percentage of verified content is traceable and verifiable. Finally, you can see many other speakers have already showcased their verification statement. We are very proud. We had the opportunity to issue the very first recycled material verification statement in China. It's really a showcase project for us. All I wanted to say is that why we have to talk about the verification in this project, because verification is really through the check of the qualified technical experts from the independent third party that we can provide a single source of truth that is building trust, credibility, and ensure what all you claim is compliant with internationally recognized standard. And of course, in today's, we call VUCA world, it's a lot of geopolitics and also disruption of supply chain. So this verified projects really provide your supply chain, your suppliers with resilience and transparency. Finally, also is from my personal wish, we are very happy to see the fruitful result of this project. As one of the speakers mentioned, is now we really would like to see how we can take it to grow at a scale, make this circular project really to be applicable to wider industry to accelerate the circularity in the automotive sector. And thanks again for GIZ for initiating such an innovative project.
Thank you all. And before we open fully to the floor, we have a question and some comments from Jochen Hardt, particularly around, I think, the question of scalability, which was brought up at the last one, and what particularly surprised you, and what main learnings, because as I think from our last panel, and now into this one, what we see very much is we are approaching a very crunch time. In these pilot projects, these examples very much will be hopefully the norm in 6 years or less. So what would be your immediate takeaways?
Yeah, good afternoon, ladies and gentlemen. John, thanks for the introduction. Jochen Hardt from Covestro. Our corporate vision of Covestro is we want to become fully circular. And that's the reason, or one of the reasons why we sit here. I think we have a tremendous task ahead of us as an industry, how to become fully circular, how to recycle things, how to do that in the right way, and how to scale this, because this is not easy at all. We are engaged with engineering plastics in many industries, so we have long-term experience, particularly in China, because there is a very well-established recycling industry, so there's a certain reason why did we do this in China, apart from the initiative and thanks to GIZ and the partners to do this. So also this collaboration is key in this point. No company can do that alone. We need the whole value chain to do this. And experience we had already, for example, from the electronics industry, in the IT industry, where we have, example, EP regulations. In order to sell a laptop in certain markets, you need to comply with this and show this standard. So we have 10 and more years of experience how to do that. And we have meanwhile recycling rates, 90%, even 100% recycled content. It works, and the industry is meanwhile working with that. And this challenge is ahead of the global auto industry. And I would say in terms of magnitude, it's even larger. We talk about 90 million cars, global car production annually. I talk about passenger cars in terms of definition. And if you look at the average content of engineering plastics, which is growing for good reasons, lightweight, it's about fuel efficiency or energy efficiency in terms of battery capacity, we need to recycle this. And the fundamental problem, and now I'm back to the thing we have shown now in this pilot project, and thanks to the participating companies, that in the collaboration throughout the whole value chain, all the way to the certification, that we are not greenwashing, that this is real and we are doing the true, real, good thing. It needs collaboration across the value chain in order to make it work. And you can see later at the Covestro booth, the parts, the Volkswagen part and the Neo part is there and other parts. It works, technically it's possible, up to the highest standard, Class A surfaces, meeting all specifications and requirements, and also safety regulations. We talk a lot about safety in automotive, not only aesthetics. The point is scalability. We have a certain established value chain in China where we have access to feedstocks, but the problem is we need that globally. And no company alone can do that. It needs a similar setup as we sit here on stage, across industry, across OEMs, material companies to establish such things. We need to establish capacities, invest into things, dismantling of cars, sorting, into refining of materials, all the way into repolymerization processes, if you go through the route of chemical recycling or mechanical recycling routes. So and this needs investments, and this takes time. ELV is 6-7 years ahead of us, 2032 latest. This is tomorrow. And we will have upcoming regulations in China, regulation in a positive way. It's very supportive, from my personal experience, what the government does to support the industry to really fulfill these targets. And we see the same in Japan happening. So all major auto markets, other regions I'm confident will follow, are going in this direction. So we'll get a fight for resources, for feedstocks. In Europe right now, RV materials, what we discussed here and show later, it's 100% sourced out of this product in China. We have no access in Europe right now. So and this is something we need to build, and this is a huge challenge and a call to action on behalf of the materials and chemical industry. We need that. We need, from this 90 million cars, we need something back, dismantled. We need feedstocks, refined, pure, and then we can make the world circular, combined with green energy and other intelligent processes.
Thank you very much. Are there any questions from the audience?